Next rule you'll have to know is the product rule. This can be used in a lot of different applications. Again, I put a mnemonic device here. This is how I have it memorized. So basically in my head, whenever I'm doing the product rule, I do first times derivative of second plus second times derivative of first. Okay, so for number 4, we are going to have to use the product rule. Again, just note that we have two different functions being multiplied together. So in order to do this, to get p prime, we're going to do the first times the derivative of the second, which is just e to the x, plus the second times the derivative of the first, which is secant squared x. If this is slightly challenging for you, what you can do is you can do this more step by step. I kind of just did this in my head and combined steps. So what that would look like is I would write f equals tangent of x, f prime equals secant of x, g equals e to the x, g prime equals e to the x. And then you would just plug it into the formula. So whatever way works for you. Okay, but either way, we would end up getting p prime here up at the top. And then from here, we're just going to go ahead and simplify this. So let's just just rewrite it with e to the x in front. So it's nice and pretty. So there we go. So it looks like this would be equivalent to answer choice A. However, we could also simplify this by factoring out our GCF of e to the x. So we could bring that out front and we would be left with this here, which is answer choice B. So the correct answer here would be C, which is both A and B. Okay, now for number 8, this is actually going to be a combination of the product rule and the chain rule. So let's start with the product rule. We're going to do the first times the derivative of the second. Up to you if you want to write this out formally using U sub. I'm not going to. I'm going to kind of just do it in my head. So the derivative of e to the 3x would just be itself times the derivative of 3x, which is just 3. So again, I use the chain rule there. Feel free to write it out further. That's just me kind of being quick and just kind of skipping through that. Okay, and then we're going to do plus the second times the derivative of the first. And again, I just used the power rule there. Okay, and of course, this is f prime equals. Now, let's go ahead and just clean this up. So let's see, what do we want to do with this? Let's write it as 3x squared e to the 3x plus 2x e to the 3x. So we do have a GCF here of e to the 3x, so let's go ahead and factor that out. And then we would be left with 3x squared plus 2x, which would be answer choice B. Okay, so for number 11, we are going to have to use a combination of the product rule and the chain rule. So let's go ahead and start off. So let's start with the product rule. So we are going to do the first times the derivative of the second. This is going to require the chain rule, so I'm going to write it off to the side here. So I'm going to let my u equal x squared plus 1, which would make my u prime 2x. And then I'm just going to rewrite this as ln of u, and I'm going to take the derivative of that, which gives me 1 over u times u prime. Now I'm going to go ahead and plug back in, and I'm going to get 1 over x squared plus 1 times 2x, or 2x over x squared plus 1. I'm going to just kind of write a little line here just to keep that separated. So going back to the product rule, we have first times derivative of the second plus the second times the derivative of the first term, which just using the power rule there gives us 3x squared. Now we just have to go ahead and clean up and simplify this big mess we have. So for our first term, we would get x cubed times x squared. It gives us 2x to the 4th over x squared plus 1 plus 3x squared times natural log of the quantity of x squared plus 1. All right, last thing we could do here is we could factor out a GCF of x squared coming from this term and this term. So we would get x squared times 2x squared over x squared plus 1 plus 3 natural log of x squared plus 1. And that would, of course, all equal to f prime. Okay, in this question, we are going to have to use a combination of both the product rule and the quotient rule. So let's go ahead and jump right in. At the highest level, we're going to start with the quotient rule, which is low d high minus high d low over low squared. So low times the derivative of the numerator. I'm going to write that again off to the side here. So in order to get that, we're going to have to use the product rule. So we are going to do the first times the derivative of the second plus the second times the derivative of the first. So let's go ahead and plug that back in here. So we're going to get e to the x cosine x plus sine x times e to the x. All right, so we just did low d high minus high times the derivative of the denominator, which is just 1. And I should put parentheses there like so. And then this is all going to be over low squared, or just x squared. All right, so now all we have to do is clean this up. So, and this would be r prime equals. All right, let's start off by just kind of distributing this x into everything. So we would get x times e to the x cosine x plus x e to the x sine x minus e to the x times sine x over x squared. All right, so you probably see in your numerator here that we have a GCF. So we have this e to the x in every term here. So let's go ahead and pull that out. I apologize. I don't know why that just took away some of my writing. So hopefully we can move on without that. So I would get e to the x times x cosine x plus x sine x minus sine x all over x squared. And this would all be equal to my r prime.